apologize.
What was it?
No worries.
Quiz from Friday.
Don't worry about it.
I probably got my
All right, so you had to do 1 through 4, and then for the graphs that followed, you only had to do in behavior, and we're doing all the rest of that today. Any questions on that? End behavior. It depends on what we get through today. Downstairs.
We'll get you this chart next time.
Will you get to use the chart on the test? No.
What chart?
I use the chart on.
I tried not to use the chart so that I could look at it. It looked like a graph.
Yeah. All right, let's talk about some other characteristics then. This is more polynomial. You're going to definitely need your calculators today. Where is it? Come on. I'm sorry. All right, by the time we finish polynomial analysis, you will have 10 or 12 things that you're finding for every polynomial. So far, oh my God. So far, we have done in behavior, and that is it. Sullivan, when do you leave? Thursday? So you'll... Oh. So you'll leave Friday, and you'll be back when?
I'll leave
And then you'll come back when?
on Wednesday.
Not the next Wednesday, but the next Wednesday. Nice. All right, you ready? So we talked about in behavior, so you should be good on in behavior. Now, the next thing we're going to talk about is called turning points. What are you doing? Which is probably why you shouldn't be in my chair and you should be in Dozier's chair. All right, turning points are exactly what they sound like on a graph. Okay, turning points are the place where the graph turns or changes direction. It's the humps. You're exactly right. It's like the humps that are on the graph. So if I think about a graph, all right, Sunny and Sarah Ann, if y'all will put the phones away, please. If I think about the way a polynomial graph looks, and let me just do an example of one here. Something like this. What do you think the degree of this one will be? What type of, bless you, what type of polynomial, bless you, might this be? 4, degree of 4, which is a quartic. Okay. Look at how many humps there are, right? So this is linear, quadratic, cubic, quartic. Every hump adds another degree, essentially. All right, so turning points where it changes direction. Let's start looking at this graph. As I move left to right, just like I read a book, okay? As I'm going this way, the graph is going which direction? Up. We call this increasing because left to right, it's moving up. The point where it stops increasing and starts decreasing happens at this very highest point. Do you agree? Here's where it stops, and now it starts, as I move left to right, it starts decreasing. So this is called my turning point. It's also called a relative maximum. Do you see why that would be called a maximum? It's a high point on the graph, okay? Maxes happen when I change from increasing to decreasing. You think so? Which means minimums would happen where? If maximums happen from increasing to decreasing, minimums would happen decreasing to increasing. Or at the bottom, as Miguel says. So here I would have a minimum. And here, but that's why we call it relative. Because it's a turning point. All turning points are maximums or minimums. It might not be the highest or the lowest point on the graph, but in relation to right where it is right there, it's a low. So we call it relative. But no, that's not. You bring up a good point because this, while a relative, is also what we call an absolute max. Do you see the difference in the absolute and the relative? Everything's a relative, but you have only one absolute. And you don't have to have an absolute. It's absolutely the highest point ever to happen on the graph.
But not every graph has
You can call it relative or absolute. It's kind of like, it's kind of like every square is a rectangle, but every rectangle is not a square.
So not every graph has one.
So everything can be called a relative because it's relative in its area. Not every graph has one. That's right. If you look at this graph, it doesn't have an absolute minimum because they go down forever, right? But it does have an absolute max. Does that make sense?
The absolute graph has to be.
Correct. That's correct. That's correct. So this one has no absolute. Yes, if what was positive. What would cause it to be positive? What has to be positive to make it? No, I thought you were with me there for a minute. No. If the leading coefficient was positive, it would cause them to open up. And so now I don't have an absolute max, but I do have an absolute minimum. Okay. So this would be a relative min. This is a relative max. This is the absolute min. Now I could still call it a relative min because in this area it's still minimum relative to that, but it's also an absolute. We want on your sheet, I don't think, the reason I'm striking that is I think on your sheet it only says relative maximum to minimum.
Every absolute is also relative.
That's correct. All right, so we're looking for turning points. So the question becomes, how do I find these values? So take out your calculator. What? Oh no. Miguel. Okay, look on with somebody beside you because I only have one more right now. How nice of you. Okay, I was going to say, don't throw my calculator, Berger. Come on now. Y'all are so much more attentive sitting like this. Is it because I keep calling y'all out for putting your phones and your computers away now? Well, and you can't talk to why. I have done my job efficiently today. I deserve a... That will catch up to you soon enough. We are but through.
This is your last year exam.
What?
Your last year, last year.
What's that got to do with anything? Huh? I'm talking about in this class. Because right now some of you are doing so well because you learned so much in Algebra 1 that you went further than what others did. It'll catch up. Okay. Speaking of catch up now. Okay. I do know problem. I used to teach honors problem stats. Miss Phelps. No. No. So all of your odd functions, if they're odd degrees, because they go in opposite directions, they will have no absolute anything. Right. Everybody hear that question? So depending on the way the ends go, so if you're an odd degree function going in opposite directions, then you're not going to have an absolute anything, right, Sullivan? Okay. Good. Would you stop? She's new this year. New to us, not new to teaching. Like teaching this lesson. Okay. No, we have to. This is critical. All right, let's consider this graph. Your calculator is going to be your best friend through a lot of this unit. I'm not going to make you. All right. We're not going through, you know how specifically we graphed quadratics with exact points, with stretched and shrunk, and we did everything exact and precise. We're not going to be quite that precise as we graph these other polynomials, which is why you need your calculator. There will be some points that we are that precise with, but not all points. So if I've got this graph, I know this is a cubic, and already I could tell you the end behavior of this cubic. What is it? Is positive odd, which means as x approaches positive infinity, what does the graph do? It goes up. And as x approaches negative infinity, what does the graph do? It goes down. So no matter what else is happening in between, my graph is doing something like this on the ends. Do you agree? Odd and positive. The degree is odd and the leading coefficient is positive. So that 4 square chart you have, it would be in positive odd. 1. One's positive. You look at the leading coefficient. The leading coefficient here is positive. The degree is odd. Degree is 3, leading coefficient is 1. So if it's odd, they go in opposite directions. You just have to determine if it's this way or this way. Positive means it goes positive, positive, negative, negative. If it's negative, it would be opposite. Right, it's a cubic, so it's going to have a massive. She is. No, it wasn't. It said attendant assistant. Okay. Are we okay in behavior here? No. Sure. Yes. So it's okay. If you're still looking at the chart, that's okay. Listen, if you can think of one easy example, it'll help you because they're all like that. Like if you can think of one easy odd degree function, I'm thinking a line, with a positive leading coefficient, so a line with a positive slope. Whatever the ends of that one does, that's the same behavior that all odd positives are going to have. I know what you're saying. Yes, yes. For odd ones, that would work. However you can remember it. You just have to remember those four scenarios. Okay. Let me test your knowledge here a little bit. What would the y-intercept be? How do you know? How do you know? Put 0 in for every x, it leaves you with 2. That means it's crossing the y-axis at 2. So now I don't know anything about this graph without graphing it, but I do know the degree is 3. I know what the ends are doing, and I know what the y-intercept is. Without even calculating anything, I've gotten that much information. Does that make sense? Okay. Let's talk about the turning points. Take out your calculator. That's what the end's going to do. No matter what's going on inside of here, that's what the ends are going to do. Can y'all tell I'm dreading this? Okay. Go into y equal, yeah. That's the degree, and it's odd. All right. I feel like we may have calculated some of this stuff before. Am I losing my mind? Have we calculated? We calculated zeros, didn't we? It's going, pre-cal in this class, or just 3 preps is a lot to teach, especially when we're doing similar stuff. I know. I think I have a brain tumor or something. I'm going crazy. Okay, y equals. Let's type this in. X to the third. Oh, those are all the broken ones. I gave all the math on all the calculators. 2 each their own device, I suppose. Right. Yep, y equals, and just type the equation in. So x to the third, everybody knows that this is the x button, right? That's the button that gives you the x variable. X to the third minus 6x squared plus 7x plus 2. Zoom 6 for a standard window, so I'm in a 10 by 10 window for x and for y. Zoom 6. That's okay. Okay, Emma, y equals, are any of these highlighted in black up here on your calculator? Hit quit and hit y equals. None of those are highlighted black. Did you input this correctly? You used minus and not negative here. Okay, let's do this. Let's find a Everybody got this on your calculator? All right, here we go. Zen 6. You should have this. Everybody's calculator graph looks like this, yes? Tell me how many turning points you see on this graph. 2. What are they? What is this one? No, like what kind of turning point? Relative max. What is this one? Relative minimum. Am I increasing or decreasing as I come up to this? Increasing. How about here? How about here? Everybody good? All right. Oh. All right. Second, here's the hard part. Second trace. Second trace. I'm going to work on this first maximum first. Notice I have all these different values that I can calculate. I am going to choose maximum because I want to find that maximum, that relative max. So choose max. Second trace. All right, I'm on max. Again with my spider, right? We have worked with the spider in here, right? I'm not losing my mind. Okay. This says left bound, so that means make sure your spider is on the left side of the maximum, somewhere left of the maximum. Make sure you've cleared it. Here's the max. I'm on the left. I'm going to hit enter. And then it says right bound. So I'm going to move to the right until I have cleared it, and I am going to hit enter. Then I hit enter one more time. I'm looking for a relative maximum. I need to. You don't think I did it right?
That is not a very nice number.
It's not. Oh, it doesn't matter. As long as you're to the left. I'm giving it an interval to look and say. Yeah, it doesn't have to be at the exact same spot. F5. Left. Lower is left, upper is right. So enter. Then go to the right. Enter. This is the X, that's the Y. All right. Everyone should have this value on your calculator. Yes? You didn't? You did. Everybody, let me see your eyeballs so I know you're good. Yes or no, you have this value on your calculator. Okay. Yes, yes. Okay, look, let me show you what this means. Here's this. My thing does something like this. It goes through about right here. I'm going to label this point 0.709 4.303, and you will see why in a minute, okay? So now I know. Remember, I already said in behavior, right? I said my in behavior already. As x approaches infinity, f of x approaches negative, positive infinity, just kidding. And as x approaches negative, f of x also approaches negative. I also said that my y-intercept was q. And now I know that I have a relative maximum at 0.709, 4.303. Yeah. Just put a 0 in for all the x's. All right. Here's what I want you to try to do. Calculate this minimum and see what value you get. So same process, second trace, but I'm going to do minimum instead of maximum. I know, because I want you to be able to do it. No. Don't eyeball it. It will be wrong.
I
3.29 and negative 4.30.
3.290995.
Give me those coordinates, Dozier. 3.29. And what's the y? Isn't it 909 or something?
Yeah.
That rounds up. You should always round if you're approximating. You don't truncate and round.
That's moving more accurate. That's moving more accurate.
Well, you don't get 3 decimal places. Just because I'm getting you ready, calculus is 3 decimal places, so you lose your answer point. 3 decimal places always. Yeah. Say that one more time. It is here. Here it's a coincidence. They won't always be the same. All right, some of just AP rule, college board. Like you get all your FRQs, you get so many points for everything, and it's broke down. There's always 1 point for the answer. And if you round wrong, you don't get that point. If you round in the beginning, it'll throw. You get all this other point for all the other work.
No work. It's still be work.
But if you do all this work and you get it wrong, you can actually get more points than just. All right. I'm not sure on that calculator. No, I'll have to look. All right, 3.291, negative 4.303. The question was asked, is the y value always going to be the same? That just happens to be so on this one. That's not always the case. All right, I'm going to put a mark here that that's 2. That is actually the 0.02. All right. Now, we've talked a lot about increasing and decreasing. So I want you to tell me, if I needed to name the intervals that are increasing on this graph, I'm going to use interval notation. That's why I said the intervals. So increasing intervals. Where on my graph Is the function increasing? In other words, as I move left to right, where is it going up? Use the x values. Always use x values when describing. That is exactly right. 0.709. And I'm always going to use parentheses for intervals, okay? Because they're the turning point, it's not going to include the turning point itself. Is that the only place on my graph that I'm in? No, I'm actually increasing another place as well. Where? How can I include that with this? That's exactly right. So then I'm going to pick up. Look at y'all doing all this math. And then what'd you say, Sullivan? From infinity. This tells me that it is increasing. It starts out increasing until I get to this turning point, and then from this turning point to infinity, it's still increasing. Never brackets. Increasing, decreasing intervals are always parentheses. Because if you included it, that's a turning point. It's not actually increasing at that point. It's direction at that point. No, it doesn't. It's not increasing at that point. It's not increasing or decreasing. The reason in calculus terms is because the slope of the tan line here is 0. So it has no slope. It's not going up. Calculus? Unit circle. That comes in pre-cal. Oh no, you have to memorize it. Yeah. I have one somewhere. Yes, that's exactly right. The decreasing interval, so where am I decreasing as I move left to right? That's 0.709 until 3.291. If you're ever asked for function value is your y, but when you describe intervals and you describe things like that, I'm talking about my x value, not my y value. Okay, I'm starting to lose a few of you. Let me just do domain range and we'll take a little break. How about the domain on the turning points or your maxes and mins are always the point where I change from increasing to decreasing or vice versa. The range would also be negative infinity to infinity. There's no holes, there's no jumps, there's no asymptotes, there's nothing of the sort. It goes down forever, up forever, so it's negative infinity to infinity. Not for all of them, no. What's the end behavior? As x approaches infinity, as x it's even, so they both go the same direction, and because it's positive, they're both going to go up. And that's exactly. Sullivan, you got it? You understand what we're saying? Okay. What is the y-intercept of this graph? It's going to look kind of like a W. That's right. Because it is a what? What's the type? It's a quartic. Yes. Put it in your calculator and let's sketch it out. Yay. Okay. Yes. I'm just kidding. What? Probably will be more along a pre-cal line than an interior line. I think we're actually gonna be camping that weekend. So Kenzie and I have to leave early so she can go home. I'm gonna graph this. You don't have to go if you don't want to, Wyatt. And it's okay. It is okay. All right. I don't know. I haven't done it yet. X to the fourth plus x to the third minus 4x squared plus 5. Then 6. I don't know. I got to calculate it. It looks like it, but yeah. All right. I'm going to first find this minimum. By the way, that is a what kind of minimum? Why?
Because it's not going to.
It absolutely is the lowest point on the graph. This is a what? Relative max. This is a relative min. All right. Yes. So I'm going to second trace. I'm going to start with the minimum. Start with max. All right, so here's my maximum. So I'm going to go to the left, enter, to the right, enter, and then enter one more time. Please. Okay, this is what I wanted it to do because I want to talk about this. All right, let me tell you what this means because you're going to miss this on your test if you write 1.45. Why would you miss that? Your calculator is pixelated, and sometimes it has a hard time getting an exact value, especially with zeros for some reason. This E negative 6 is really scientific notation. It's saying times 10 to the negative 6. And if you remember scientific notation, that means take this decimal and move it to the left 6 places. Anytime you see this means 0. You ever see E with a negative number, this is 0. Your calculator's just gone. Okay, 0. So this point is 0 to 5. Every single time you see E negative something, it is 0. Does everybody hear me? Amy, you got it? E with negative something, 0. 0, 0, 0. That's a maximum. That's a relative max. I did, but Sullivan asked me to start with maximum. Yeah. 0.5 there. All right, so it did something like and this point was 0.5. You're gonna have to sketch a graph. This is not accurate. Wyatt Thompson. What I just said.
Oh.
No, but it doesn't matter.
Who's that? Oh, yeah, because I didn't have it anymore to look at. I was trying to remember what it should look like. Thanks, Wyatt. Thank you. So it does more like, yes, you got to get them all. Like Pokemon, you got to get them all. Is that what they say? Got to get them all? Okay. Catch them all, Dozier, I don't know. What are you asking? Yeah, give me that value. Negative what?
Negative 1.830.
3 places. Give me the Y.
Negative 3.30 or 31.
3 places.
I know, but 309.
Oh. I didn't think you were dumb. All right, how about this one? You'll want it to be kind of like what I did here. Dozer. Does it round up? Let me see. All right, is everybody okay?
No. Who's right?
I got 1.089. Right now, I didn't.
Oh, no, I didn't.
What do we get, guys? What do we get?
Is it 8.8 or 8.9? 8.8. You're right. Look how good you're doing when your phone and your computer are put away. But you're not watching them. It's amazing what happens then. Okay, and you're taking notes, paying attention. I think it has to do with the collegiate atmosphere. Stuff like what? You don't like it? You don't like the seating arrangement? It forces you to pay attention more. There are less distractions. You don't think so? Miguel, what are you doing? You gotta put your computer away. Okay, let's name increasing, decreasing intervals, and I'll shut up and let you work on your work. Homework. Increasing intervals. 1, negative 1.838 to 0. 2. I thought you said it was 8.8.
8.8, I just forgot.
Yeah. How about decreasing? Infinity to negative 1.83. This thing gets hot. Right here, it will literally burn you where the hot air is blowing out. Bless you. And then, yeah.
All I hear is
Okay, so y'all quit distracting Emma. Sullivan, I'm surprised. All right, where else? Is that the only place it's decreasing? No, it's not. Where else? 0 to what?